Gentlemen, welcome to the last lesson that I will be presenting on Edpuzzle for equations of a tangent to a circle. We're going to look at some aspects of Euclidean and analytical here and see how they collide in the second. Again, for today, you'll need a pen, pencil, notepad, calculator, and part of the formula sheet. Well, let's jump straight into it. The equation of a tangent to a circle. There are a couple of things that you should know about a tangent to a circle if you think about Euclidean. We can see from the drawing that the tangent to a circle hits the circle at a right angle. And the reason for that is, pause the video and answer the question. Good. Well, we can see that this tangent AB is hitting the circle at D, and D and C are connected, and D and C are the radius of the circle. So what we have here quite specifically is an important thing to realize, is that this right angle comes from the property that if we took the gradient from the center of the circle, just change my pen color, if we took the gradient of the radius and we multiplied it by the gradient of the tangent, we know that that should come out to -1. And this is the essential part that we're going to be working with here today. Effectively, you're going to either get one of the two radii, work out the other, and then work out the equation of a tangent. The equation of a tangent that I'll be dealing with, usually I'm going to deal with this equation because it only requires us to know a point, which is this y1, x1, and it requires us to know a gradient. And often you'll be given this point D, you'll have worked out these two radii, and you'll be able to work out the tangent of a circle. So let's have a look at what we're going to do here. Some steps that you can follow. To determine the equation of this, first step, to get this, we need to get the equation of a circle in this format. From this format, we're allowed then to work out from the center to the point on the edge, the equation of that gradient. Once we've got the radius gradient, we then know that it's perpendicular to the tangent gradient, and so we can work that out. And then the last part is to get the equation of the straight line. So the steps you need. Step number 1, let's just label these, is find the center. Step number 2 is find the gradient. Step number 3 is find the new gradient. And then step number 4 is get the equation of the circle. And these will be what we'll be doing through today's lesson. Okay, the first example, worked example number 1. Determine the equation to the circle. Determine the equation of the tangent of this circle at the point f is -2 and 5. Pause the video and give it a try yourself. Okay, good. Let's do this in steps. Step 1 says we need to first find the center. And so to find the center of the circle, we're going to take x squared, y squared, 2y, 6x, -7 equals 0, and complete the square to find its center. So we've got x squared plus 6x, leave a space, y squared minus 2y, leave a space, and here's the 7. What we're going to add and subtract is half of these numbers, so we're going to add and add and add and add half of some number squared, and the number squared that we're going to look at will be, in this case, 6, in this case 2, so we've got 6 and 2. So let's tidy this up. What we get then in the first bracket is x plus 3 all squared, we get y minus 1 all squared, and then 7 plus 6/2 squared plus, oops daisy, that should be a 2 in the last one. Oh, thanks for spotting that. That should be a 2. Means that we're going to get 17 here. So we now know that the center of our circle is at the point -3 and 1. Okay, good. Now that we've got our center, we want to work out the gradient that links the center of our circle to the edge, which is the gradient of the radius. The gradient of the radius will be, let's just remind ourselves of what the points are. We've got the point for f, which is -2 and 5, and we've got the center 3 and -1. So therefore what we can say is that the gradient of this is 5 minus 1 over -2 plus 3. And that leaves us with a gradient of 4. Step 3 then says our new gradient, which is the gradient of the tangent, will be the negative reciprocal of this number. Part 4 then says we want to solve the equation And we already know all these components. Oopsie daisy, that should be x minus x1. So we already know the y and x value from up here, and we know the m value from here. Let's plug these in. We've got y minus 5 equals minus 1 over 4 into x minus minus 2, which is x plus 2. And if we FOIL this out, we find that the equation of our straight line is minus 1 over 4x plus 9 over 2. So again, to recap, let's make a note of what we did. We found the center, we found the gradient that links the center to the edge, to the point on the edge. We then got the new gradient. And finally, we subbed all of these into our straight line equation. And this then is the equation of the tangent that touches the point minus 2 and 5. Okay, last worked example for today. Determine the equation of the tangent to the circle x squared plus y minus 1 squared equals 80, given that is parallel to the line y equals half x plus 1. Pause this video and try it yourself. Okay, so there's a bit of sneaky work happening here, because what we've been given is the fact that the circle, which I've shown in white, has a line that's parallel to this line, the yellow line. The problem is that there are 2 points that could possibly be up here and down here. Let's just label these so we can work with them. Let's call this top one A. There's a point up here A and a point down here B. Now, if we already know that the gradient of this line is equal to a half, there must be another line that links A and B that would be perpendicular to this line. And so the gradients of that line, the gradients of the green line, would be the negative reciprocal of those two. And so what we have then, I suppose you could hopefully realize, is that the equation of the line, the green line, will be y is equal to minus 2x plus 1. It's a perpendicular line to the line that we had above, passing through the same point. And that's going to be quite useful for us, because what we can then do is use the equation of the circle x squared plus y minus 1 all squared equals 80 and try see where does that touch this line, 2x plus 1. We can do a straightforward substitution here, so x squared, we're going to have minus 2x plus 1 minus 1 in the brackets is equal to 80. And when we tidy this up, what we get then is x squared plus 4x squared equals 80. So 5x squared equals 80. And so therefore x squared equals 16. So x is equal to minus 4, or x is equal to plus 4. And I guess what we could then do is plug the minus 4 and the 4 back into the original equation, and we get 2 corresponding y values. And the 2 corresponding y values we'll get is that when I plug in minus 4, minus 2 times minus 4 plus 1 is 9, and when I plug in 4, minus 2 times 4 plus 1 is minus 7. So what we get then is that A's coordinate, let's just label it here, A is going to be minus 4 and 9, and B is going to be 4 and minus 7. Okay, so again, we've got 2 points, and both of those points are on the circle, and they must both therefore be parallel to y equals half x plus 1. So let's solve on the A side first. Y minus y1 equals m x minus x1. I'm going to plug in the points from above along with this gradient. And so what we get then is y minus 9 equals half of x minus minus 4, which is x plus 4. And so what we get for this equation will be that y is equal to a half x plus 11. For the b side, we got y minus y1 equals m into x minus x1. I'm going to plug in the coordinates from b and the gradient that we're sharing. And I'm going to FOIL this out, and we find that y is equal to a half x minus 9. And these are the equations of the 2 tangents to the circle. I hope you've enjoyed this section. It's quite short and sweet. You're going to be practicing quite a lot of these today, building up then towards quite a long worksheet that will happen to consolidate all the pieces you've done so far. If you've got any questions, please get in contact with your teacher. Have a great day.